subscribe to our channel and hit the bell icon so that you know when live we go. Your exam is on 4th of October. Now less than 2 weeks are left. During this time, you should not be stressing yourself by reading more. Rather, the best way to utilize this time is to solve some mock test. It will serve two purposes. One, it will keep your nerve under control during the exam because you would have practiced tests before actually giving the prelims. And secondly, you will be covering many themes of last 1 year through these mock tests. So the important topics you will be familiar with, you will be having more confidence on the morning of the exam. We have designed 2 tests under pre-parikshan program. There are 200 questions based upon 200 important themes of last 1 year. Today the second test has been launched. I would encourage you to attempt both the tests and see if you are getting around 90 to 100 marks. If you are getting, then you are doing okay. It will also boost up your confidence that you have covered enough topic. Also, please note that to accommodate more number of students, we have extended the date for pre-parikshan 2020 full test 1 till 21st of September, but only till 9 am of 21st September. And the result for the first test will come on 21st by 2 pm. The registration link is given in the description below. Register yourself and test yourself on the same parameters on which UPSC is going to test you. Now let's begin with the discussion of today's newspaper, The Hindu, dated 20th September 2020, Delhi edition. The articles that we shall take up for discussion has been tabulated on the screen and the time stamping for the same has been given in the description section. This article is from page number 9. It has been titled, Tata Group to unveil India's first CRISPR test. This CRISPR test is to detect the presence of coronavirus in our body. The testing kit has been termed as Feluda. Feluda was a detective character in the work of legendary filmmaker Satyajit Ray. A similar testing kit termed as Sherlock using CRISPR technology already has been developed by some Western companies. But Feluda will be an indigenous technology developed for the first time in India. Feluda, or in general the CRISPR test to detect coronavirus or in general any virus, is very, very important. The reason being, it will enhance our capacity to do the testing of coronavirus until a vaccine is developed and distributed. Also in our syllabus of GS paper 3 under the science and technology section, biotechnology has been mentioned. And questions in prelims and mains are repeatedly asked from this area. UPSC has asked a question in 2017 on Cas9 protein. And again in 2018 in a question, reference to CRISPR-Cas9 was made. CRISPR-Cas9 is an emerging technology that will revolutionize biotechnology and our life. New application of CRISPR-Cas9 technology is emerging, and one of the emerging application is the detection of viral infection in our body. See, development of coronavirus vaccine is going to take some time. And even when it is developed, the task of distributing it to various corners of the globe will be a Herculean one. So the herd immunity through vaccine is going to take at least 1 year. In the meanwhile, it's very important that the testing for coronavirus is made very efficient and reliable. Presently, we have 2 kinds of testing for coronavirus. One is called as rapid antibody test. This test is very fast. This is just like a pregnancy test. You have a strip of paper. In that there are artificial antibodies. And when a sample from a person's navel tract is brought in contact with that strip of paper, if there are proteins of coronavirus present, then those proteins will bind with artificial antibodies and the test result will be given as positive. You all must be familiar with the fact that the surface of coronavirus or in general many virus have spike proteins, and these proteins help the virus to enter into our cell. An infected person will have parts and parts of these proteins broken and circulating all around the body. It will be everywhere, in the stool, in the saliva, in the nasal fluid. So any kind of fluid from a person's body as such can be used for this test, but generally nasal fluid is taken because it is supposed to carry more viral load. But the problem is that this is very rudimentary kind of test. There is no biotechnology involved as such. There is no multiplication of the genetic material of the virus, as is done in case of RT-PCR test. So the sensitivity of rapid antibody test is very low. If there are few viral material, then the test will turn negative. So if a test is negative in rapid antibody test, that does not mean that the person is not infected. The person has to go for RT-PCR test. But if a test is positive in rapid antibody test, then surely the person is infected and you do not need to go for RT-PCR test. So the problem is not of accuracy, the problem is of sensitivity. If enough viral load is not there, the test will be negative. But it is helpful. It is helpful in a sense that if the test result of rapid antibody test is positive, then you need not go for expensive and time-taking RT-PCR test. RT-PCR test is considered as the gold standard in viral detection. It stands for real-time polymerase chain reaction test. And to increase the sensitivity, segments of DNA are created using an enzyme called as polymerase. And polymerase chain reaction signifies that the DNA fragments are copied exponentially. Meaning from one fragment, 2 fragments are created, from 2 fragments, 4 fragments are created, and from 4 fragments, 8 fragments will be created likewise. So this process increases the sensitivity of the test. When billions of copies are created, then the test will be highly sensitive. And if there were few materials to begin with, then the test will always come positive. So even at the initial stage of infection, when the viral load is very low, the test will still come positive. But then it requires a laboratory setup. It cannot be done through handy kits. So it cannot be done in the field. The test will have to be done in a laboratory. And the test takes 4 to 8 hours. But the total time required for the sample to be sent to laboratory and the report to come from laboratory could be 1 to 2 days. So it's a time-taking test. And this one is a low sensitivity test. So the testing of coronavirus cannot be done efficiently. And this problem can be solved using CRISPR-Cas9 technology. CRISPR-Cas9 based coronavirus testing will be fast and will also be reliable. But to understand how the detection of coronavirus will be done, first let's look into the basics of working of CRISPR-Cas9 technology. See, CRISPR is the name of technology. It stands for clustered, regularly interspaced, short palindromic repeats. So CRISPR is the name of the technology and Cas9 is the name of a protein, an enzyme, which does the job. We will not get into the detail of how it does the job because that is beyond the scope of civil service syllabus, but you can visualize Cas9 as a scissor. It does the job of scissoring. Cas9 is a protein that acts as a scissor. CRISPR-Cas9 technology was developed as a gene editing technology. It can go and cut the gene and bind the 2 segments, or it can insert another segment and then bind the 2 segments. So it can delete or it can insert a segment in the DNA. And we know that segments of DNA have genes, and genes have the codes for the entire physiological function of our body. So the application of Cas9 is beyond our imagination. It can change everything. It can change the way we look. It can change the way our body functions. It can remove genetic diseases. It can add additional physical features of our body, the color of our eye, the curl in our hair, the tone of our skin, everything. It can even change the physiological behavior of our body. This technique we have come to know from the natural defense mechanism found in some bacteria. Look, bacteria are constantly attacked by virus. To deal with this problem of infection by virus, bacteria uses an enzyme called as Cas9. This enzyme has the memory of virus infection. So this is used to identify and eliminate any predetermined genes. When the virus will enter into the bacterial body, it will have its genetic material. And that genetic material is identified by Cas9 present in bacteria, and then that is cut off and made harmless. The reason why this is very significant is that gene editing can be done within the body. It can be done very effectively. It can be done very cheaply. Previously, gene editing was not done inside the body. So for treatment of diseases like sickle cell anemia, the cells used to be brought out of the body treated and then put back into the body. But now the treatment will be done within the body very effectively and in a very cost-effective manner. Now let us look into the functioning of CRISPR-Cas9 technology in a little bit detail. The Cas9 protein carries a cRNA or CRISPR RNA. This cRNA is actually the scissor. This does the job of cutting the nuclear material. The specific location of the genetic codes that needs to be changed or edited is identified by another RNA present in the CRISPR-Cas9 system, and that is called as guide RNA. This guide RNA keeps looking for various genetic material in the body, and when there is an initial match, then it starts to open up the genetic material to look for a perfect match. And when successfully guide RNA identifies the presence of nuclear material, then CRISPR RNA comes and does the job of cutting. So that segment from the nuclear material is cut off. Now the harmful part is cut off. So the virus will not be able to combine with the proteins of the bacteria or human body. So it will be rendered useless, functionless, harmless. After cutting down a segment from the nuclear material, either the rest of the two parts will be joined or some portion delivered to it will be inserted in between. So deletion of the gene can happen and insertion of the gene can also happen. This is the basic working of CRISPR-Cas9 technology. Now the question is, how can it be used for detecting coronavirus? See, first of all, a sample from a patient is taken and then amplification of the genetic material as it is done in the RT-PCR test is done. After that, an engineered CRISPR-Cas9 system is inserted into the system. As we have discussed before, the CRISPR-Cas9 system will have a guide RNA. This guide RNA detects a nuclear material for which it is designed to detect. And in the artificial CRISPR-Cas9 system, the guide RNA will be designed to detect the RNA of coronavirus. And the guide RNA will detect and bind only with the RNA of coronavirus. Once the binding happens, then Cas9 protein gets activated and it starts cutting the nuclear material around it. This time it is not specific because it is an artificially designed Cas9 system. It will cut all the nuclear material around it in non-selective manner. Intelligently what is done, reporters are added in the system, and when the Cas9 is doing its cutting job, the reporters also get cut. So the signal from these cut or uncut reporters are actually taken and indirectly the presence of coronavirus is detected. So unlike RT-PCR test, direct detection of the nuclear material of coronavirus is not done, and that is why it is rapid. If the reporters are in the uncut state, then they get binded on the strip at one location, and if they are in the cut state, then they get binded on the strip at a different location. And depending upon where the signal is coming on the strip, you get to know whether the test is positive or negative, just like the pregnancy test. So actually gene editing is not done using the CRISPR-Cas9 technology here. It is only the scissoring activity of the CRISPR-Cas9 technology, the cut, that is used actually to detect the presence of coronavirus. This is a novel application of CRISPR-Cas9 technology. And this has opened possibilities of many other applications of this Cas9 technology, because this simple scissoring and this simple innovation of adding reporters have not been used before. This has simplified the entire process and enabled to make simple kits that can be used on ground with higher sensitivity and lesser time of detection. There is an article on page number 12 with the title, Protection Against SARS-CoV-2 May be Short-Lived. SARS-CoV-2 is basically COVID-19, the name of the virus which is presently infecting humanity. This news is very important, especially in the context of India becoming the country with second highest number of infection. There have been cases worldwide and including India of reinfection from COVID-19. See, coronavirus are actually very common virus which keep infecting mammals and birds, including human beings. And the first infection of coronavirus in humans were identified in 1920s. So this virus has been known for a long time. and enough research has been done on coronaviruses that commonly infect human beings. All coronavirus are RNA-based virus. A virus either has DNA or it has RNA. It does not have both. And the family of coronavirus is RNA-based. In human beings and also in birds, coronavirus infect the respiratory tract. And you must be aware of lungs-related complication that has happened to many coronavirus patients. The need of ventilators have arisen, and recently you must be reading about shortfall of medical oxygen supply to many hospitals. So coronavirus infection basically affects the respiratory tract. Now it is well documented that out of 7 commonly known coronavirus that infects human beings, for 4, the protective immunity does not last more than a year. Protective immunity means general immunity against the virus. Either that is through vaccine or it is through the immune response. So you have to know it as a fact that reinfection is a common feature of all known human coronaviruses. But since COVID-19 or SARS-CoV-2 is a new strain of the virus, so we do not know how this is going to behave. But the hypothesis is that just like other human coronavirus, SARS-CoV-2 will also cause reinfection in human beings. And just like others, for SARS-CoV-2, protective immunity will not last more than a year. But to confirm this, a time period of 1 year has to pass and data collection has to be very strong. You have to keep the data of many patients because you don't know who will be reinfected. So once a patient is reinfected, the data of first infection has to be there to match. See, initially in 1980s, reinfection of coronavirus was documented through antibodies test. You know, when a person gets infected, then antibodies are generated in his body. Antibodies detect the antigen, which is part of protein on the virus, and once detected through the killer cells, it kills the virus. Antibodies are generated as a response to infection. So if there are increased level of antibodies, that is considered as a state of infection. So initially they used to detect the level of antibodies. If there is a high level of antibodies, then the person has been infected again. But now very advanced techniques are used. Genetic sequencing is now used to detect not only infection, but also the strain of the virus which is causing the infection. Today we know the entire sequence of coronavirus. So if a person is infected, the genetic sequencing of the virus that has caused infection can be known. That can be kept in the record. And when the person is infected again, then again the genetic sequencing can be done of the virus that has caused the infection. And that can be matched. And then it can be analyzed whether the same virus has caused the infection or a mutated version of the virus has caused the infection. That way we would also know if the virus is mutating, and if yes, then how fast. And using this technique of genetic sequencing, people from all over the world, including from India, have been detected to be reinfected. This reinfection is a cause of worry because initially it was thought that herd immunity will be reached in few months. And once the herd immunity is reached, then the community will get immune to infection and normal life can be restored. But since people can be reinfected, it implies that herd immunity cannot be achieved without vaccination. So the state of lockdown and the constant fear among people will continue until vaccines are developed and distributed. But the problem is not only this. From the documented study of common human coronavirus, broadly recognizing antibodies could not provide broad protection from subsequent infection. See, the thing is, suppose this is the RNA of coronavirus. When the mutation happens, mutation does not change the entire sequencing of the virus. Mutation happens in some area. And there are certain areas in the virus which does not change. So a different strain will have a different genes in some area, but some area will remain same. So antibodies which recognize this area will recognize all the strain of the virus. So it must work against all the strain of the virus. But it is found that even broadly recognizing antibodies, they do not provide broad protection and people are reinfected every year. Secondly, researchers have not found too much variation in the strain of the seasonal coronavirus. So, reinfection is not on account of mutation and production of different strains. And if this is true, then vaccination will not serve much of the purpose. And this has huge implication in the development of vaccination. First of all, because there are high chance of reinfection, so the vaccine may not be completely protecting against the virus. And even those who have been vaccinated, they may need to get vaccinated every year to protect themselves from reinfection. So what we might end up is using seasonal shots, just like the case of many flu, because new variant of the virus would take over from the older one in the population. And the variation would be different in different areas. So these seasonal shots have to be different in different regions. That will further complicate things. At this point in time, we are not very sure whether reinfection will be very common in case of COVID-19 and whether there will be common mutation of the virus. And if there would be mutation, so a careful mutation study is also required in case of COVID-19. And the component of the virus which will not be changing as a result of mutation, meaning the conserved immunodominant areas, they must be identified and they must be used to make the vaccine. As these areas will be common to all the mutated virus, so a common vaccine may be effective for all of them. But as we have seen that in case of common human coronavirus, reinfection happens and it cannot be stopped, just like flu. God forbid, if that is the nature of COVID-19 as well, then the fear is that vaccination may not be very effective. There is an interesting article on page number 12, Tracking Cases Through Sewage Analysis. This article is very important for the mains exam. It gives a very good idea of monitoring and surveillance of COVID-19 cases at population level. Look, you know that the nuclear material of the coronavirus, which is the RNA, as COVID-19 is RNA-based virus, that will be present throughout the body once a person has been infected. So it will be present in all sort of body fluid. It will be there in your saliva, in the nasal tract fluid. It could be there in your sweat. It could be there in your urine. It will also be there in your stool. So the municipal sewage water, which will contain most of the human waste, could tell a lot about the prevalence of COVID-19 at the population level. The exact data collection on infection comes very late. Many people are asymptomatic, but still they will have RNA of COVID-19 and still somehow that will go in the sewage water. Then many people go for the testing very late and then some time is required for the testing as well. So we get the data through the hospitals with some time lag. But municipal wastewater can raise an advanced alarm bell. And based upon that data, some kind of planning, maybe the number of hospital beds, the number of ventilators, these can be prepared in advance. Sewage water analysis has been done in some areas of US and it has been found that it can signal about the rise in cases 2 days before the samples are actually collected in hospitals and 4 days before hospitals take admissions and 6 to 8 days before the positive results are reported. Although you don't have to remember these, but you must be aware of this idea that if surveillance has to be done at community level, then municipal wastewater at the appropriate stage of treatment can be used. There is a short article on page number 12 with the title, Is the Moon Rusting? See, the mineralogy mapper on Chandrayaan-1 has given the data which shows the presence of oxide of iron, specifically hematite, Fe2O3, to be present at the high latitudes of the moon. Astrophysicists have been suggesting that this presence of hematite is because of oxidation of iron on the moon's surface by the oxygen from Earth's upper atmosphere. And this conclusion has been drawn because there are more hematite on the lunar near side than the far side. Near side means the side of the moon facing the Earth. Always the same side of the moon faces the Earth. Moon is tidally locked with the Earth. We can always see only one side of the moon. The other side is never visible to us. So the side that we see is the near side and the side we cannot see is the far side. And the fact is that more hematite is on the near side, meaning the side facing the earth. So this implies that the hematite formation has something to do with the oxygen from the earth's upper atmosphere, because the near side is more exposed to the earth's atmosphere. But then the question is, how come there are some hematite on the far side? Because if earth's atmosphere is responsible for formation of hematite, then there should be absolute absence of hematite on the far side, because it does not have contact with earth's atmosphere. But we know that water is present on moon surface, and if iron reacts with water, that will result in formation of iron oxide, and this iron oxide is further decomposed to give hematite. This also happens in the near side of the moon, but then this process is accelerated by Earth's upper atmosphere oxygen, and hence there is more amount of hematite on the near side. Then the hematite formed at the lunar craters of different ages can help us understand about the oxygen of Earth's atmosphere in last 2.4 billion years, their percentage in the atmosphere, and the kind of isotope that was present in the initial phase, because that has been logged in the hematite of moon. And hematite present in different layer on the surface of the moon will tell a lot of story, and different layers can be accessed through the craters on the moon surface. So researchers are hoping that NASA's Artemis mission can bring some hematite sample back on Earth for further analysis. NASA's Artemis mission is to be launched by 2024, and this mission will carry the first woman and the second man on the surface of the moon. This mission will have lots of sophisticated technology, and carrying back some hematite to Earth will be an easy task. There is a news article on page number 10 with the title "External Debt Increases Almost 3% to $559 billion at March End." See, recently Department of Economic Affairs under the Ministry of Finance has recently published the report India's External Debt, a Status Report 2019-20. And according to this report, there has been rise in the external debt by 2.8% in last 1 year. The private sector debt has increased by 4.2%. Since the report gives the data for until March end, the time around which COVID-19 began to have hold on India, so this has now become irrelevant. The external debt will overall increase much more than 3% in the coming times. But it does tell something that even before the impact of COVID-19, the economy started to come under stress. And recently released GDP data tells the same. Here we'll just have a short discussion on external debt from the perspective of prelims examination. In the prelims of 2019, this question came. We will discuss this question after a short discussion on external debt. See, external debt is exactly what the name says. It is the total money owned by government, corporations, and Indian citizens to foreign creditors. The foreign creditors could be the foreign government, the multilateral institutions like World Bank, IMF, AIIB, or any other institution. It could also be private commercial banks. For the analysis, external debt is seen under various categories, like for example, short term, which is less than 1 year, and long term, which is more than 1 year. The external debt is also categorized into sovereign debt, which is the debt of the government, and the non-sovereign debt, which is the debt of private sector. The major heads under which external debt of a nation is analyzed are these: multilateral debt, the debt from the multilateral institutions like Asian Development Bank, AIIB, World Bank, IMF, institutions like these. Debt from other sovereign countries come under the head of bilateral debt. Then there is a third head, trade credit or export credit. Loans and credits extended for imports directly by the overseas suppliers. Sometimes the overseas supplier themselves give the loan to the importers or for general trade purpose. That would come under trade credit or export credit, and will also in general include the loan taken from foreign banks and financial institutions for the purpose of trade. There is one very important head called as external commercial borrowing. And these are the borrowings coming from commercial banks or other commercial financial institutions. It could be of government, it could be of private sector. The non-resident deposits in banks and financial institutions are also considered as external debt and is seen as one head under the external debt. Now there are certain things which are very important for prelims exam. You must have a rough idea as to what percentage of GDP is India's external debt. At the end of March 2020, it was 20.6%. Out of this 20.6%, non-government debt was 17%, and the government debt or the sovereign debt was 3.6%. Non-sovereign debt is a much higher chunk of external debt. External commercial borrowing accounts for 40% of external debt. It is the largest component under external debt, and that is followed by non-resident deposits. Around 81% of external debt is long-term debt, and the remaining 19% is short-term debt. Short-term debt are those having maturity less than 1 year. You must also know that India's external debt is in various currency, but 53% of that is in US dollar, and the remaining would be in rupee, yen, SDR, and euro. Now let's come back to this question. Consider the following statements. Most of India's external debt is owned by government entities. Wrong? Overwhelmingly large chunk is of private sector. All of India's external debt is dominated in US dollar. All. That sounds so incorrect. So actually the answer would be D. Now let us do question for the day. Yesterday's question was, consider the following statements. Bamboo is a grass. True. Assam is the largest producer of bamboo in India. True again. Third statement was, bamboo is considered as tree in non-forest area for administrative purpose under the Indian Forest Act 1927. It used to be so until 2017, but then through an amendment to the Act, bamboo is not considered as tree in the non-forest area. So now bamboo can be cut and the trade would be eased, but in the non-forest area. So the answer would be option B, 1 and 2 are correct. Today's question is this. Consider the following substance. Iron, water, hematite, molecular oxygen. Which of the above are found on the surface of moon? 1 and 2 only, 1, 2 and 3 only, 1, 3 and 4 only, all of the above. Today I have not given you the quiz in the DNS itself. I'll be making some good quality questions and post it as DNS quiz on ELEARN platform. So please attempt that quiz.